All right, hello. Welcome to Permutations with Duplication, Part 1. And to understand this, or to illustrate it, I've set up the same three cards again. And we know when there's three different cards, A, B, C, and we're using all three, and we're setting up arrangements or permutations, there are 3 factorial or 6 ways to arrange them. Okay? Now, suppose, on the other hand, some of the cards weren't different. Suppose you had an A card, and then you had another card that was B, and then you have another B card. Okay. Well, suddenly these arrangements don't all look so different. And to illustrate that, I'm going to put in a 1 and a 2 and show you. Like, let's say I proceeded as before, and I set up my arrangement. So I had maybe the A, then I had B1, and then I had B2. Okay, that might be one of my arrangements. Then another arrangement might look like this. B2 followed by B1. Now here's the problem. These look exactly the same. All right, now I could keep listing arrangements. I could go with, say, B1, then A, then B2. But then I could flip the two B's, right? And again, you can't tell these apart. They actually look the same. And lastly, we could do something like, I don't know, we'd do the B1, B2, and then A. And then we'll flip the B's again. We're always flipping the B's. And really, this should count as one arrangement. Okay, this should count as one. Because to the untrained eye, they look the same. I see a BAB and a BAB. Okay, and do the same thing over here. Okay, so when you don't have, like, I mean, I put in the 1 and the 2, but really that nobody sees this, right? I'm just illustrating how do we get, if you've got some duplication, how do you get the right answer? We can see that really the arrangements are A, B, B, or they're B, A, B, or they're B, B, A. There's really only 3 arrangements to the untrained eye. So how do we get the right answer? Well, we know the right answer is 3. So let me show you how we get the right answer. You start off and you say, oh, there are 3 cards. So it would have been 3 factorial in a perfect world, but wait, I can't tell these B's apart. So really what's happening is I'm getting twice as many arrangements showing up. I don't want to count them all. See, what you have to ask yourself is how many ways are there to flip the 2 B's around? Well, there would be 2 factorial ways to rearrange the 2 B cards, and that's what we're doing here. So we have to divide 3 factorial by however many ways we can flip these duplicate cards around. And if you work this out, 3 factorial divided by 2 factorial, that's the same as saying 6 divided by 2. We get the right answer. Now what I'm going to do is I want to show you how this works with another more complicated example. I think it'll make it very clear. So we'll clear off the screen here. Suppose you had the letters in the word cheese. So you had C and an H and an E and an E and an S and another E. Okay? So there are 1, 2, 3, 4, 5, 6 letters. Okay. Now, if all 6 letters were different, then we would have 6 factorial as our answer. That's how many permutations there would be. But now we have to look at the duplication. There's an E here, and then there's another E, and another E over here. So in other words, we can't tell the 3 E's apart. So if somebody came along and maybe they wanted to, they could spell cheese like this. You know, they could set up the order with an E1 card there, the E2 card there, and then the E3 card over here. But why couldn't they flip around all 3 of these E cards? Well, they could, and we'd never know the difference. It still spells cheese. So what's happening is we're getting 3 factorial too many arrangements happening. See, the word cheese is going to happen 3 factorial more times. So what I got to do is I got to divide this by 3 factorial. And that's accounting for this flipping the e's around and causing these, what really permutations that look the same. So now I just got to work this out. 6 factorial divided by 3 factorial turns out to be 120. Okay? And that is the correct answer. I guess in closing, the trick to understanding this is that what you have is, technically speaking, 6 factorial is correct. That's how many arrangements there are. The problem is that when we flip around the 3 E cards, we can't tell them apart. So we're getting arrangements that actually look the same. And so we don't want to count those as different arrangements. So this is the key. This is how you correct that. All right, well, I'm going to stop there. We're going to come back with some more examples on this in just a bit.